Big welcome to everyone, and thank you for taking the time to tune in. I'm Lucy Watson, co-founder at Cioda, and I'll be leading today's discussion, which is entitled AI within Financial Services, the Data Challenge. Now, we all know that artificial intelligence is transforming financial services with an ever-growing list of applications, starting out with the obvious candidates, things like high-frequency trading, customer profiling, chatbots, underwriting. But these days, it's starting to spread its tentacles into pretty much every aspect of how firms identify value and measure risk. But is it delivering on promise? And what's stopping us from getting more value from our AI projects faster? Well, according to McKinsey's September 2020 publication entitled The AI Bank of the Future, one of the top 3 challenges holding banks back in their journey to AI is a weak core technology and data backbone. And that's going to be the topic of our discussion today. What are the challenges around getting the right data into these models, and how do we address them? And to do so, I'm going to be talking to 2 industry veterans. Firstly, I have Greg Soulsby, who, as well as working within financial institutions and regulators in London, is heavily involved with the startup Model Drivers, which brings model-driven semantics to data and regulation within the financial sector. And secondly, I have Patrick Stanton, who has spent over 20 years building and implementing data processing and reporting systems within investment banks across the globe. And about 5 years ago, he founded Cioda, which is an R&D intensive startup that has developed some innovative technology that addresses some of the fundamental challenges around data that he'd seen investment banks knocking up against time and time again. So, to kick things off, perhaps I could start with you, Greg. Banks have loads and loads of data. They are very accustomed to producing gazillions of reports on a daily basis. Could you talk me through why supplying data for the purposes of AI is so particularly challenging?
Yeah, sure. AI applications have a data kind of profile, not dissimilar to many applications that banks face have already, like, for example, regular reporting or loading data warehouses, all require very broad scope of data and very large volumes. So banks are used to grappling with those kind of issues. But in addition, AI requires as broad a scope of data as possible. So lots of external data. There's no end to the amount of data you can throw at AI. There's going to be a rapid rate of change. Reg reporting platforms, data warehousing, they change. But with an AI engine, you want rapid turnaround in your ability to make changes and add scopes of data. These are extra challenges that AI application projects face over and above what banks are already dealing with.
Well, thank you, Greg. So, could you talk me a little bit through how these challenges are impacting the success of the AI projects?
Yeah, well, a number of things, but in my negative experience on AI projects is that the traditional kind of approaches, data warehousing, is too slow for the AI environment. You can get an AI project up and running quickly, an AI engine running quick on a narrow scope of data, on predefined scope of data, but immediately have that running. Everybody wants to start improving and iterating, and you immediately run into the problems of the slow rate of change and the inability of the project to keep up with the requirements of the business.
I somehow find that a little bit perplexing because you've got AI is an area that huge amounts of investments are being poured into. You've got growing pool of talent. You've got a lot of focus, very rapid pace of innovation. Why is it that these fundamental data challenges aren't getting solved?
Yeah, well, look, the move to the cloud, for example, the technology stack of the cloud, Amazon's and that, it really has made a massive difference and enabled all this to happen. But they're not the AI stacks on the cloud don't tackle, for example, the big issues that AI face, like the semantic problem, the thing that we deal with. The scope of data is incredibly wide, but there's nothing new in these stacks. There's new technologies that is helping the business people, the analysts, the people writing the models to understand the semantics of their data. An AI model might require input from dozens of data sources, but possibly even hundreds. Each one of those data sources has got its own data structures, its own business rules, its own data quality problems. Nothing in these new stacks is addressing that side of the coin of data quality and those other things. And the semantic side. I was watching a video the other day on how to use the Facebook neural network AI engine, and the chap said that when we start this tutorial, please realize you're going to spend 90% of your time getting the data together and 10% of your time building the model. My experience, I would have said 80-20, but I think there's a consensus here that the scope and the problems of semantics and bring the data together is what is the real bottleneck, and nothing that's innovating is particularly helping that. Or, hopefully we'll come to some options, but that is what's holding people back.
Okay, thank you. So to sort of summarize, for me it sounds like AI can do some really clever stuff, but there are two distinct data related issues that are holding it back. Firstly, we've got the practical side of bringing together this disparate data in vast volumes from lots of different places, both accurately and robustly, and also in a way that accommodates change, because the pace of change is rapid. And secondly, we've got the problem of interpretation and understanding, because much of that data may be held in ways that are somewhat obscure or not very well understood. Would that be a fair summary, Greg?
Yeah, no, sure, absolutely.
Okay, thank you. Moving on to Patrick, you spent most of your career tackling the first of those challenges, that of bringing together this disparate data. What are your thoughts in terms of what's not working, and where we perhaps need to start thinking differently about how we approach data?
Well, traditionally, banks have approached this problem by bringing all of this disparate data together in a central system, and then bring it in the format of the use case that system is initially designed for. So if you've got, for example, 50 front office systems with all your, generating all of your trade data, and you feed that into one central system, up front you end up designing a data model for your known use case of what you're going to use it for. And then for all of those 50 systems, which will all be in a different data format, if you're lucky, some of them might be in industry standard FPML or close to it. I don't think anyone actually generates fully compliant FPML that I've seen. And then so you need to then transform all of that data into your data model. But the problem is you're then fixed yourself to that data model. So if you want to change anything, you have to change your data model that you're using. You have to change the interfaces to extract that data from the inbound data. And that is a huge barrier to initially building the system and a big barrier to changing it. Now, the firms have traditionally put all their data into a data lake, but it's the traditional data lakes. It's very hard to get your data out of it in any way that is timely. So that's another big barrier to its usage. And then when you've got if you use a modern big data analytics database, a lot of those then lack the consistency, but you still also have to have that central data model to map to. And then also a lot of these analytics systems aren't really set up for doing complex financial queries against complex financial data. So there's many barriers to being able to get that data together in a way which is useful for AI.
Yes, Patrick, can you say something about the data quality issues you see within that story?
Yeah, sure. Well, if you're taking data in from many different systems, you've got a synchronization, just at the most basic level, the timing. So typically, if you're running analytics type functions across a data set, it'll be on a static data set. But if you've got 50 different systems feeding that data in, how do you know that the point in time at which you're making that processing for your or querying against that data to feed your AI algorithms is consistent across 50 different systems? One system might be feeding data real time. It might have a delay of minutes. Another system might be only a few, tens or 100 millisecond seconds. And another system might be sending end-of-day batch files of its data to you. So synchronization in terms of timing at the most fundamental level is a big issue with this.
So Patrick, if conventional approaches to data consolidation aren't working for purposes of AI, what else might firms want to consider?
Well, you can take a modern approach of schema on read, which is essentially working with a virtual data model, not the physical data model which the data is saved in. This gives you a great deal of flexibility because you can design a data model you need as and when you need it. So for each specific use case of your AI logic. It eliminates the necessity to have ETLs, those small, typically not always small, but those pieces of software which sit between each data feed and translate it to a central data model. So you don't have to design a central data model up front. You don't have to build transformation software to transform the data in and out. And it enables you to dynamically create and change your data model as and when you want to. And you can quite literally do it in minutes with the right software rather than months of design, code, and deliver processes.
So how much do you see this approach being used in the industry?
Well, I've heard of bits of some of the tier one banks using it. There are technology companies out there who have implemented schema on read for its obvious advantages. So it is about. It's not widely adopted, but it is being used.
And what's your view on is this the future, do you believe?
Yeah. I mean, it's absolutely the future. Just to the sheer fact of saving time and money and being able to move far more rapidly.
Okay, thank you. Moving on now to the second data challenge that we highlighted earlier, that firms struggle to understand and interpret the data they already hold, let alone starting to bring in new external sources. Greg, what are the how might these firms tackle some of these issues?
Yeah, look, thanks, Lucia. I'm a bit of a Tesla fanboy, and Elon Musk, a bit of a hero of mine. One of the things he says, you might have heard him say, that he's building the machine that's building the machine that's building the machine, and I learned a lot from that. So he's the car is the Tesla cars are the machine. The factories are the machines that build the machine, but he's building the team that's building the factory that's building the car. The machine that builds the machine that builds the machine is what he's building. And I was sort of inspired by that. So I think we're doing something analogous with data and what the technology kind of the semantic technology that's sort of heading us in that direction. So if you don't mind, I'll show you a diagram trying to explain that. So in the bottom row here, you can see the applications. So the applications are the machines that manage our data, and the development teams are the machines that build the machines. So you can see here on this first row along here that the development teams work with the data models, the business rules. I'm looking at the sort of semantic side of things that they deal with that, the data models and things like that. But each one of those is an individual artwork. The reason why 80-90% of the time of an AI model builder is on data preparation is that there's no machine that builds the machine that builds the machine. They're not congruent, they're not consistent, and it requires a massive amount of human effort to wire them together, these different domains together. So you can see here, we call that the structured view of a particular domain application, a domain-specific language, the language that you use to talk about that domain, the business rules, and in particular, it's a machine. There's software, there's tooling around managing, to help you manage the language and use the language in design and that sort of thing. But that doesn't help integrate those. So the machine that builds the machine that builds the machine is this top layer here, this meta model, right? And that's the language you use to, and the tooling you use to write the domain-specific language tooling, the machine that builds the machines, that build the machines that manage the data. And this is going to give us congruence, automation, and auto-generation of code, all these things. That's what we call the digital twin. You know, the way engineering firms build factories, they build a digital twin, and then they build the physical factory to replicate the digital twin. And I think this is the direction for semantic technology and for banks. Is they're going to be working much more with digital twins, and like Elon Musk, abstracting themselves out of the kind of day-to-day issues of managing, you know, data itself, and they're going to be building the machine that builds the machine.
Wow. So it sounds like there are some very promising technological innovations, both around the sort of physical consolidation of the data, and then around the sort of the interpretation and understanding of that data, so that it's being used correctly and efficiently. And that collectively, these really have the potential to supercharge our AI endeavours. As a final question, perhaps I could ask each of you, is there anything else on the horizon that you predict could transform data for AI? Perhaps if I start with Patrick, please.
Well, the other thing is the history of data. So a lot of financial data, once you've taken it out of the system, or you take a snapshot from the system, you've only got the data as it was at that point in time you've taken it. And if you store it in a lot of the currently existing data stores, and you update it, you override the history. Now, some systems will store that history in an audit log, but that's quite hard to get at. So if you wanted to look at your data at a point in time in history, you have to unwind that data, basically go get the previous data from the audit log and add it back to your data to be able to see what it was at a point in time in the past. Now, one way around this is, well, the best way around this is to use a time series data store. So you're storing an immutable series of facts, so a centralized distributed ledger. And that way you can access your data at any point in time in history without any compute cost. There's other complexities to it. You will also need a time series index to go with it, because if you're going to query at a point in time in the past, your query needs to be accurate at that top point in time in history. You can't just use your indexes in your query to be as at now and look at the data it was in the history, because you'll get a skewed data set. So there are complications with that, but I do see that as another thing which is going to help AI to be able to have that history as well.
So presumably, and correct me if I've got this wrong, that would enable you to kind of build up a catalogue of the world as it was at historical points on time, which presumably one could then use to perhaps, train an ML model. Would that be correct? I mean, maybe that's a question for Greg. I don't know.
I mean, I'm not a machine learning expert, but you can then present the data. A consumer of that data can then, if you've got a time series data store, that it can then step through history, looking at the changes through history, which from my understanding is a very powerful aid to learning.
Yeah.
Fantastic, thank you. Greg, how about you? What do you see on the horizon?
Well, I think coming back to first principles, what's going to solve this problem of 80% of your time spent on data aggregation before you can start building them using an AI application. And from first principles, you've got to ask yourself, how can we solve the sort of the part of the problem that's the water underwater? The iceberg's 10% above the water, 90% below. How do we solve the data problems within the systems, the source systems, in order to feed them into the AI engines? And one very exciting opportunity here, I think, is in semantics and a bit of semantics called inferencing. I'll call it an example of inferencing. So inferencing is not AI in itself, but it is human-like thinking. So an example might be if Greg is in London and London is in England, then we can infer that Greg is in England. And if we can apply that kind of relatively simple technology in-house, in the applications, in the core systems, we can apply that kind of human-like thinking to the management of our data within our systems, then we're going to make it much, much easier for the AI applications to understand, interpret, and pull out the data, massively reducing that 90% of their time people's time spent on gathering data.
So it sounds to me like you're almost saying a gradual path towards merging the sort of world of operational data and the world of sort of AI data. Would that be a fair summary?
Yeah, excellent. I don't see it as either or. Most AI projects I've seen are standalone. Right, they take feed.
Yeah.
They're not trying to push. They're not trying to integrate back into the core systems, and certainly from a data management point of view, they're not using the possibilities that are there, are emerging, and are there now in-house for data management.
So we're talking about a closer integration between those worlds, which today are still very distinct.
At the moment, they're considered distinct, and I'm seeing the future they'll start to merge. Yeah.
Fascinating and a very profound shift from where we are today. Well, first of all, I'd like to extend a big thank you to both Greg and Patrick for joining the discussion today, and to everyone who has been listening in. If you'd like to find out more about any of the topics we've discussed today, whether it's more about how you consolidate, consume and interpret FPML, or whether it's about the flexibility of schema on read, how to set up a digital twin, or develop a better understanding of your data semantics, please do click on the link below to schedule an exploratory call. Thank you.